Let's talk about cabling. Ethernet uses its own kind of cabling, and it's gone through several generations of cabling throughout its life. The most modern implementation of it, and the one that you see used most often, is these Category 5, Category 5E, and Category 6 cabling. These categories are defined by the EIA TIA, which are Telecommunications Industry's standards body. And these types of cables are really just meant for passing different speeds of traffic through it. Cat 5 is designed really for 100 meg Ethernet. Cat 5e was designed to go up to gig Ethernet. And then Cat 6 cabling is designed to handle gig and potentially higher speeds than gig. Now, the way these category cables are set up is actually really cool because it uses some nifty physics in order to accomplish it. Now, I'm a complete physics nerd, so I really get into this stuff. You don't really need to know about it in order to be a network engineer, but knowing how these Cat5 cables work is actually kind of slick. So, the way it works is anytime we pass electricity through a wire, what will happen automatically is that there will be a moving magnetic field generated around the wire. If you watched Mr. Wizard's World when you were a kid, you may have remembered him making an electromagnet like this. Now, if you pass electric current through a wire and it generates a magnetic field, that should mean if you pass a magnetic field over a wire, it will generate an electric current. This is true. This is what Edison did to generate the generator or the dynamo. And that's exactly what they do. They move a bunch of electric wires past a magnet and it generates this huge electric current and delivers power to your house. Now, the big problem there now is if you take two electric wires and you put them right next to each other and they're nice and straight, and you pass electric current through one, that'll generate a moving magnetic field, which is right next to another wire, which will then make the current jump from one wire to the other wire. Because when you move a magnetic field past a wire, it generates an electric current, and when you move current through a wire, it generates a moving electric magnetic field. Why is this problematic? Well, here in a Cat5 cable, we have 8 wires, and we use 4 of them for transmitting data. Well, if we ran those wires straight, and we put them all right next to each other, and we sent data across them, what would end up happening is our data would consistently jump from one wire to the other wire and cause this issue called crosstalk. And crosstalk is a huge problem because when crosstalk happens, this is where we're going to start dropping bits from our Ethernet frame and have to do lots of retransmits. Exactly what we do not want. So what engineers have done is they've twisted these cables together. They've twisted 2 wires at a time together at a very precise number of twists per inch. What this does is it disrupts the magnetic field that's being generated as electricity is passed through one of the wires. And because it disrupts the field, it's unable to get the signal to jump from one wire to the other wire. Now, as we go up in the category, we can handle more and more data speeds. It also means that the quality of the copper has to be better. It means that the twists per inch has to be very precise. And it also means that we have to separate and twist the 4 pair of wires separately as well. So if you look carefully at this picture of the Cat 6 cable, this yellow one over here, cut open, you'll see there's this plastic strip in the middle. And that plastic strip in the middle is actually a twisted piece of plastic so that in each side there's a little corner for the wire to fit in. And it actually twists all 4 wires at a very precise angle so that we prevent as much crosstalk as possible. Now you see this cable on the bottom here too. Looks a little bit different because it has this shielding jacket in here. There's some metal jacket on here. So these 3 at the top are called unshielded twisted pair or UTP. This one at the bottom is generally called shielded twisted pair or STP. So we have UTP type cables and STP type cables. And they can all come in any one of these varieties. So we can have UTP or STP Cat 5, UTP or STP Cat 5e, same thing with Cat 6. Why do we need the shielding? Well, the shielding prevents something called electrical magnetic interference or radio frequency interference, which are kind of the same thing because radio frequency and electromagnetic frequency are all part of the same spectrum. Regardless, what this is to prevent is when you're running network cables, you need to always avoid running network cables across highly electromagnetic intensive things. Like you don't want to run your Cat5 cable across a bunch of fluorescent lights. It will destroy your throughput. You have to use shielded twisted pair cable for that. You don't want to run your cable past some radio transmitter in your office. You need to use shielded pair for that. The idea, though, is to avoid all of these sources of highly electromagnetic interfering devices, which are typically devices that put out some large amount of power. Like I said, like fluorescent lights are the biggest culprit that I know of. Okay, so that's the cabling. Let's talk about how we construct it, because we actually use this Cat5, 5e, and 6 cabling in more than just Ethernet applications. It's just one of the most popular applications of this cabling.